So next we are going to see about the edge computing. So edge computing is the distributed computing paradigms which that involves the processing a data which closer to the source of data generation, and rather than really solve on centralized data centers of cloud computing. So the key concept of edge computing is to bring computing resources very closer to the data source, which reduces the latency and enables the real-time processing and analysis of data. So edge computing is often used to support applications and services that require low latency, high bandwidth and real-time precision, which making capabilities and such as autonomous vehicle, industrial automation, remote monitoring, augmented reality and smart cities. So this is the format for edge computing architecture. So we have three layers. One is cloud layer, edge layer and device layer. So the cloud layer will focus us about the big data processing and data warehouse, and edge layer will focus us about the data processing and reduction, data catching and buffering, control response and virtualization. And here the edge node and server, that is LAN or WAN, it can be formed by using the used to connect. And next we are, and third layer is device layer. So device layer means the device can be anything which we have connected by the edge computing. It can be car or watch, anywhere, or mobile, the persons or industries by connecting the wi-fi by device. So IoT and edge computing. So the proximity of data source, the edge computing brings a computational resource which is closer and location where data is generated by IoT. Or this proximity reduces the latency and enables faster response time for processing and acting upon the data. So the real-time processing, by processing data, the IoT application can achieve real-time insights and response. This is very crucial for time-sensitive applications such as industrial automation and smart cities and healthcare monitoring and enhancing and reliability. So distributed edge architecture ensures that IoT system remains resilient and operational even in the event of network disputes or failures. So the data processing and decision making can continue locally without rely on continuous connectivity to the cloud. So next is bandwidth optimization. So that is edge computing minimizes the need to transmit large volumes of data over the network of centralized cloud server for processing. So only relevant data or insights are sent to the cloud and optimize bandwidth usage and reducing cost. And next is security. So edge computing enhances the security by processing sensitive data which locally at the edge and minimizing the exposure of data to potential security threats during the transmission over the network. So the key concept of edge computing for IoT. So here we have used the decentralized architecture, proximity to data source and low latency. So the edge computing involves a distributed computing resource such as processing power and storage and closer to the IoT device and sensor at the edge of the network. So this decentralized architecture reduces the dependency of centralized cloud servers, which enables the data by processing occurs locally. So the proximity of data source, um, in edge computing of for IoT, the computational resource or position closer to the location where data is generated, and this proximity minimizes the latency by reducing the time and it takes for data travel between the device and processing node. So latency, one of the primary objectives of edge computing and IoT is to reduce the latency or delay of data from transmissions. So next we are going to see about the fog computing, edge device gateways and scalability. So edge computing architecture are designed as scalable, allowing them to handle varying workloads and accommodate the growing number of IoT devices. Devices and gateways is a entry point for the data generated by IoT sensors and device. Fog computing is a subset of edge computing that extends the concept of decentralized further into the network which closer to the IoT device. This is the component of edge computing. So things which is powered to the cloud by using the communication edge computing networks. So the benefits of edge computing, it's more efficient, the greater employee productivity and reduced IT cost, and functional is remote locations and data sovereignty. So the application of edge computing is fraud detection, traffic management, better supply management, real-time video analysis, and crop monitoring, and improved patients outcomes. And some of the applications you have already seen there. And further trends is edge AI integration, future is 5G integration and edge computing at the edge, so which involves the encompasses the distributed and localized development. So the combination of edge computing, decentralized architecture and proximity of data source with IoT interconnected network of devices is driving innovation, efficiency and intelligence across diverse user costs.